All right, so on Friday, which I know you all were here for, we talked about surface area. So what's the difference between surface area and lateral area? Because there is a difference, right? Which one is smaller?
Lateral.
Lateral. Why?
Because it's just from like
It's just like this. It's just what, though?
the
It doesn't include the top or the bottom, right? So it doesn't include the bases, it just includes the walls. So for instance, in number 1, you just did the sides and the front and back. Or in the bottom one, you just did the outside part of the can. All right, but the surface area includes the top and the bottom. So the surface area is always going to be bigger. So what we're talking about today then, because we did surface area of prisms and surface area of cylinders on Friday, we're going to talk about surface area of pyramids and surface area of cones today. So again, you're going to get formulas, but you need to know how to use them. You need to know how to plug it in. So there's a little bit of vocab that goes along with this because there's some parts to pyramids and cones that we probably haven't seen before. So we're going to go over those parts. Once you have those parts, you should be fine to plug them into the formulas. And again, guys, I'm not testing you on can you memorize a formula. I do not care. I will give you all the formulas. But if you can't utilize them, you're only as good as... It's like saying, oh, I have a calculator, so I don't need to know how to do any math. That's not true. If you don't know how to use your calculator, it's not going to help you. Okay, so these are regular and non-regular pyramids, but you would do it the same way. What kind of pyramid is this?
Hexagonal prism.
What?
Pyramid.
Why is it a hexagonal pyramid?
Because it only has one base.
Well, yeah, the pyramid because only has one base, and it's a hexagonal pyramid because the base is a six-sided figure. It's a hexagon. Okay, so all of these faces are what shape? Triangles, except the base, which is a hexagon, which is a hexagon. So to find the lateral area of a pyramid, the lateral area is just the triangles. The surface area includes all the triangles and the base, so whatever's on the bottom. So you're only adding one thing to it. So the formulas for this are as follows. I'm going to write them a little bit bigger. All right, so the formula for a regular pyramid for lateral area is 1/2 of the perimeter times the L. And L is the slant height. So slant height means basically how tall the face is. All right?
Was it the H?
It's like the area of a triangle, right? So the area of a triangle is base times height divided by 2. So the reason that lateral area is 1/2 of perimeter times slant height is because this is basically like saying 1/2 of all of the bases, because perimeter is just all the way around, right? So it's all of the bases times the height. So this formula comes from the area of a triangle. All right? L is for slant height. I don't honestly know why it's an L. Maybe because there's an L in the word slant. I don't really know. But L is slant height. So in this one, the blue line is slant height. Whereas this red line going up the middle is the altitude, which would be the height of the what?
Pyramid.
Actual pyramid. It's the height of the actual pyramid, whereas the slant height is the height of the what?
The triangle.
Triangle, so the face. The slant height is the height of the face. So a slant height is height of the face. Okay, and then for surface area, it's still the same as this because you still need all the lateral surface area, but then you add large B. And in this case, large B just means area of the base. So because a pyramid can have any different type of base, we just say large B is the area of the base because we don't necessarily know what that figure is going to be. So if it were a rectangular pyramid, then base would be length times width. If it were a parallelogram, it would be base times height. If it were a hexagon like it is here, we would use 1/2 apothem times perimeter. But again, if you ever have to do this from here on out, I will give you the apothem. So you shouldn't have to use like tan or special right triangles to find it out. Okay, if you ever have to do these for these equations, you'll get the apothem. Alright? So big B stands for what?
Base.
Area of the base.
Area.
So find the area of the base and add that to the surface area. Or sorry, the lateral area. Okay? Alright, so a regular square pyramid. So the first thing I'm going to do is draw it just so I can get it in my mind what it looks like. And I don't draw good 3D figures, so forgive me ahead of time. Alright, but you get the rough idea. Okay, so a square pyramid means that all the base edges are what? It's a square, so that means they're all what?
The same.
The same. They have to be the same. If it's a square, they're all the same. Okay? So a regular square pyramid with base edge length is 5. So if this is 5, what's this?
5.
And the slant height is what?
Wouldn't it be the
9. So the slant height is 9. So it tells you the slant height is 9. Okay? So our formula for lateral area is 1/2 perimeter times slant height. So what would I plug in here?
5, 10, 15, 20
For what?
for P.
Good. So P is 20. Where'd you get that?
I added on the sides of the
Very
square.
good. Okay. And
There's
then
9.
9 for slant height.
The way I'm lost.
What about the
Okay, so big P means perimeter. So the base of this is a square. If this is 5, this is 5, this is 5, this is 5.
20.
So that's 20. And then 9 for the slant height. Because remember the slant height is the height of the face. Alright, so what's half of 20?
It's
No,
10, and then there's 90.
10 times 9 is
90.
90. Because it's inches squared.
50.
So the lateral area is 90 inches squared. Now, last thing, for surface area, we have to do the lateral area, which is 90, plus the area of the base. What's the area of the base?
20.
90 plus
The area of 10, 25.
y.
Because it's the area of the base.
The area of the base, and in this case, the base is a square. How do you find the area of a square?
Like a
And then
10
times
times
width.
5 times 5 is 25. What's 90 plus
120,
25?
115.
115 inches squared. Alright, and again, you can check yourself because which should be bigger, the lateral area or the surface area?
Surface area.
Surface area should be larger because it includes the faces and the base. Faces and the base.
So smart.
You are all very smart. Everyone. Okay. Alright. This is a cone. A cone is, how's a cone different from a pyramid?
There's no edges.
There's no edges. That's true. Why not? What's the base?
A circle.
The base is a circle, right? So the base is a circle. All right. So the base of a cone is a circle. What do you notice about the slant height? Is it different than on a pyramid?
Yes.
Not really, because it's still the height of what? The face, kind of, except a cone doesn't really have faces, but if it did, that's where it would be. Okay, so the slant height is still the outside height, as opposed to the axis, which is like from the base to the center. So if you picture a cone or a pyramid as like a teepee, right? A teepee would have, they have like a pole in the middle to hold it up. That's the height of the teepee. That's not the slant height though. The slant height would be if you were at the top and rolled like a ribbon all the way down the outside of the teepee. That would be the slant height. So it's going down the outside of the height rather than this red line, which goes straight up in the middle. I don't care about this red line for the area, the surface area. I care about the slant height, which is the outside height. Which would be longer, the slant height or the axis? Slant height. Yeah, the slant height will be longer because the axis is going which way?
Up and
Like straight up and down, whereas the slant height is on a
diagonal.
diagonal. Yeah, it's on an angle. Okay? So lateral and surface area of a cone. The formula for lateral area is pi r L. What's R?
Radius.
Radius. And what's L?
Slant.
Slant height. Okay, so then what would be the surface area? You would do this plus what?
Plus the
Surface area includes the area of the face plus what?
the axis. No.
Area of the base. How do you find the area of a circle?
Half
Pi r squared.
I squared.
Alright, so you just add pi r squared. How come there's only one of them, whereas in a cylinder we did 2 pi r squared?
Because there's
In a cylinder it has two bases, right, top and a bottom, whereas a pyramid, or sorry, a cone only has the one base. Okay? Alright, so in this, let's identify the pieces that we need. What's r?
5.
And what's the slant height?
12.
No.
Oh, it's not, it's undefined.
I don't know right now. How can I find it?
You have
The one where you multiply with a squared.
A squared plus b squared equals c squared because this makes a what?
Right triangle.
Okay, so what's my a?
12. 5.
5.
5 or 12 doesn't really matter. What's 12 squared?
144.
144.
And what's 5 squared?
25. L. No.
C.
C. No.
I guess it could be L squared, but it's c squared. 144 plus 25 is.
169.
169.
So c must equal
169.
13. Because 13 times 13 gives you 169. So L is equal to 13. So now I just do what with these? Plug them in. Lateral area is equal to pi times r times
Square.
L.
L. So that would be,
Pi.
what's r times L?
RL.
20. No, 60.
75.
Oh my god. That's so.
65. So lateral area is 65 pi. Okay, and then what do I add to that for the surface area?
Pi r squared.
Plus pi r squared. And what's r squared?
35.
So my whole surface area would be what?
90.
95. Whenever you have any type of circles, what should be in your answer?
Pi.
A pi. There should probably be a pi in your answer. Okay? The only time there's not a pi in your answer is one if you do what? Actually multiply it out to 3.14, right? So that's okay. I will just always write them like this, as long as you can recognize that this is the same as, it would be roughly 270 something. Okay? Because if I multiplied pi times 90, 3 times 90 is 270. So it'd be a little bit bigger than 270.
Is there how you go? 144.
12 times 12. So to find the slant height, we had to do the Pythagorean theorem. Because I didn't know this, but I knew this leg and this leg of the right triangle. So you do a squared, b squared equals c squared. So 144 plus 25. Okay, go try, hang on, before you go up, you're finding lateral and surface area. This is the slant height. This is the base edge. This is the radius. And this is the slant height. You should have the slant height for everything. You should not need to do the Pythagorean theorem here. Okay? Go. Okay, so the last thing that we're going to talk about is changing dimensions and then composite figures. So same type of thing, but with changing dimensions means that something is changing. So this problem here says the radius and slant height of the right cone are tripled. Describe the effect on surface area. So what do you have to do first here? Find the original surface area. So we want to do the original surface area. And then it's a cone, so surface area is pi RL plus pi r squared. Okay, so in our original, what's our r? 3. And what's our L? Okay. All right, what about in the new one? The radius would be 9 and the slant height would be 15. Okay, so I want you four ladies to do the original one, and gentlemen, I want you guys to do the new one. So use the new height and new radius. Go. At your seats right now. No, you can work together if you need to, or just plug it into the formula. Triple. So these are your new ones. You're just plugging these into the formula.
Okay, so we're just doing the surface area?
You're just doing the surface area. The formula's right here. So you're just plugging in the radius and the lateral or the slant height for the new cone. Yes. Okay.
I think this is it.
Does it matter how you mark your column? Like this?
Oh, I don't care. As long as it looks vaguely like pi. You do it like
That's what I do.
Miguel does it like this. It looks like
It looks like
that
a
looks like
N.
yeah. All right, so ladies, you guys got 24 pi. Gentlemen, have you guys gotten it yet?
Yeah.
What is it?
216.
216 pi? All right, so 216 pi. Now, that's not the answer because the question says describe the effect on the surface area. So what do you have to do? Yes, how much it was multiplied by, right? So what do you multiply 24 by to get 216? How can you figure that out? Divide. Divide 216 by 24, and you get times 9. All right, so the effect of tripling the slant height and the radius means that the entire surface area is multiplied by 9. So if you do all this work here, and then all the work over here to get 216, and then you don't do this part, you're going to get points, but make sure you do this part because this is what the question is actually asking for. So what is the change in dimension? All right, now with a composite shape, remember that a composite is just a couple things kind of smashed together. So in this composite shape, what is smashed together? What shapes do we have here, or what polyhedrons do we have? A cylinder and a cone. So we have a cylinder and a cone, and we want the surface area of the composite figure. So you would think, I just need to find the surface area of the cylinder and the surface area of the cone, right? But remember the surface area is all the stuff on the outside. So what would not be included there?
The base of the cone.
The base of the cone and the top of the cylinder. Why? It's not on the outside. So if you were painting this, if surface area is what you would paint, would you paint the top and bottom of the cone? No, because they're on the inside. So if I'm doing the cone, the surface area of the cone is usually pi RL plus pi r squared. Which part don't I need?
Pi r squared.
Okay, so I can get rid of the pi r squared. I don't need that because I don't need the base. So I'm just finding pi RL for the cone. And then for the cylinder, my cylinder is usually pi times r times h plus 2 pi r squared. But what don't I need here?
2.
Why?
Because there's only one base.
There's only one base. So I don't need 2 bases, I just need 1. So ultimately my equation is going to be pi RL plus pi RH plus pi r squared. So then we just need to figure out the r, the h, and the l. Well, what's our r? 28. What's the height of the cylinder? 45. Okay, so I have my r and I have my h. What's my slant height?
We don't know.
I have to use the Pythagorean theorem. So I have to do 28 squared plus, what's 45? Where'd you get 45?
90 minus 45.
90 minus 45 gives you 45. Good. So I did this before, so I know that it's going to end up giving us 53. So then that means that my slant height is 53. So L equals 53, R equals 28, and H equals 45. That means this is going to be a pretty big number, so you guys should just plug this into your calculator. So you're going to do R times L, which would be 53 times 28 pi, plus R times H, which is 28 times 45 pi, plus 28 squared times pi. So go ahead and do 53 times 28, and then do 28 times 45, and then do 28 squared, and add those all together for me.
Is it 5,205?
I got 3,500.
3528. Okay, I think you included maybe one extra something, Ivan. So 3528.
Yeah.
Alright, so 3528 pi. And again, how is the composite different than if you had just done them separately? How is the composite different than if you had done them separately? What did we not include?
So the basis.
We didn't include the top base of the cylinder or the base of the cone. So you basically found the lateral area of the cone and then the lateral area of the cylinder and the bottom base. Okay, so with composite figures, you're just looking for what you either need to take out or what you need to add in. And sometimes you're adding and missing pieces. Okay, I would like you to do 9, 10, and 11. No, go ahead and do all 12, and we'll see what you guys can get done in about 10 minutes. Okay, go. At your boards.